in filtration, I'm very sure you know what it means to filter something. Like when you're filtering water or filtering something from another. Okay. So when you're filtering something from another part, right? So basically filtration is basically that same process in chemistry. It involves using a porous material. Right? It involves using a porous material. Now, you know, I'm sure you've seen when they are sieving, when they are sieving kunu or something like that, they use like a cloth. Okay, so that's like a porous material, something that allows some substances to pass through and other substances to stay. So that's what filtration is all about. The same thing, you make use of a porous material. Now, in this case, the porous material is the filter paper. What is known as a filter paper is used as the porous material. So that filter paper is used to separate insoluble particles, insoluble solid particles from liquids. Okay, when you have a mixture of insoluble solid particles and a liquid, you make use of filtration to separate them. So what happens is that the water will pass through, of course, the liquid or the water will pass through, and then the solid particles will be left on the filter paper. Okay. So it is also used in purification of water. Another application is in purification of water. And in industrial purification of water, what they make use of is called a filter bed. They make use of what is called a filter bed. Yeah? So that filter bed will use them to separate some particles, some impurities from the water. And the filter bed basically is made up of various layers of porous material. So various sizes of particles are trapped at various intervals. So that is that about filter paper. Now the most filtration. Now the most common example or the most common practical they usually do when carrying out filtration in the laboratory is they usually mix like a chalk suspension with water, they pound ground chalk and mix it with water. Right? You've seen it before. They will grind chalk and then mix it with water. And then what they do is that we set up the filter paper and the funnel. Okay, so then when they pour the mixture through the filter paper setup, what happens is that the chalk particles get trapped. Okay, then you have the water. Now, at the end of filtration, you have two components formed. Okay, or you have two parts. You obtain two parts at the end of filtration. The first part, okay, which is the liquid, is the filtrate. And then the second part, which remains on the filter paper, is the residue. So that is what happens in filtration. So that is basically all you need to know about filtration. So do you have any questions? No question. So we'll move to the next one, which is floatation. So as the name implies, okay, let's say you have a mixture of also solid particles and liquid, okay, and then due to some characteristics, some of those particles relate to what floats, so that they can be separated. So that's what floatation is all about. And floatation basically is seen mainly in metal extraction industries. Metal extraction industries. Now, you have, I'm sure you've heard of ores, metallic ores like iron ore, tin ore, zinc ore, okay? Metals, metallic ores. So, an ore is basically just the raw form or the raw material in which or how you extract metal in the first place, like a rock. Ores are like in form of rocks, but that's how metals eventually. Those ores are processed to form the normal metals we have or we see every day. Now those ores, okay, are extracted like that from the ground and mined that way from the ground. Okay, so when they are mined that way, they contain some impurities. Right? right? Because of course they are excavated from the ground. So they contain what certain impurities that needs to be removed in order for the metallic ore to be further processed, okay, to form the final product. So what happens is that the metallic ore is ground, okay, like they grind it into like powder form, and then when they grind it into powder form, they mix it with water. Okay, so when they mix it with water, the particles will be allowed to settle. Okay, so the metallic, what is required will settle down, and then the impurities will now float on the surface and then will be separated. Okay, so that is what happens in flotation. Okay. Well, okay, and also for some ores, okay, for some lighter ores, is the impurities that will settle and then the metallic ore will float. Okay, so it could be one way or the other, but usually, okay, part of the mixture will float and then the other part of it will settle. Okay, so that is what happens in flotation. So we've looked at filtration and flotation. So any question on those two? No question, right? So let's look at the third one we have, which is evaporation to dryness. Okay. So this one is basically used for solutions. And a solution is made up of two parts, right? The solvent and the solute. Okay, two parts, solvent and the solute. Now, the solvent is the liquid portion, while the solute is the solid portion. Okay, so let's say you have a solution of salt and water, right? The salt is the solute, which is the solid part, and then the water is the solvent, which is the liquid part. Okay, so the solution is made up of those two parts, solvent and the solute. So like we said, evaporation to dryness is of course seen mainly in solutions, and it is often used to obtain the solute, the solid part, okay, from the solution. Are you there? Yes. So now, as the name implies, evaporation to dryness. Evaporation to dryness. Now, evaporation, of course, is the process where liquid, okay, turns to what, or is turned into what, vapor, into gas. Okay. So when you have a solution made up of what, of the solvent and the solute, the liquid part and the solid part. Okay. If you want to obtain the solid part, which is the solute, okay, what is often done is that the entire solution is heated. When the entire solution is heated, the liquid will start evaporating. Okay, and as it's evaporating, it's doing what? It's leaving the solution. It's leaving the solution, evaporating. So eventually, all the liquid will evaporate, and what you have left is the solute. So you would have successfully separated what? The solvent from the solute. Okay, so you have so if it's salt, if it was a mixture of salt and water you have your salt left, and then the liquid would have gone. Okay, so this method is usually used where the solvent isn't very valuable to you, where the liquid part isn't very valuable to you, where you don't really require the liquid portion. Okay, so this is the separation technique we use, evaporation to dryness. And like the example we mentioned, it's often used in the salt making industries. Salt making industries. Okay, so the normal salt we use, the table salt we use, is often gotten from salty water bodies like oceans and seas. Okay, so of course when they get it, it's in solution form, that is liquid and salty. So oftentimes they will make use of this evaporation to dryness to obtain the solute, that is the salt, okay, the powder salt from that solution.